couple of quick introductions. So again, Hashmap, we've been around since 2012. This is the only Hashmap slide, by the way, so I will keep it short and sweet. We focus in the cloud, data, IoT, and AI ML space, based out of Roswell, Georgia. If you guys know Atlanta, it's about 30 minutes north of the airport there on the Norcross side of 400. We also have our office out here off of 99 and I-10, not too far, 15-20 minutes away. And then we have an office in Toronto and one in Pune, India as well. About 150 people total. And we've got, overall, we work with a lot of industries. Obviously here in Houston, we spend a lot of time with oil and gas, industrial space, but other companies as well. Conn's Home Plus, for instance, retailer up in the Woodlands, is a client of ours. And I'd like to let people know, we actually don't resell anything. If you need Snowflake subscriptions, I'm going to tell you to call Mark, call Candace. If you need an Azure, AWS, or Google subscription, I'm going to tell you to call those guys. We don't resell anything, so we are strictly professional services and consulting. To set your mind at ease, I'm not here to put any kind of an order on the table for you. We have done, in partnership with Snowflake, some recent projects with Netgear, Devon Energy, and Chesapeake. Chris will probably tell you more about those a little bit later on. Really interesting projects that have gone very, very well. Clients have been exceptionally pleased with the time investment that they've had to make, which compared to other solutions and technologies has been quite small, as well as the people required to make that happen. Chris? So, go ahead and advance it just a little bit too. So from a Snowflake standpoint, started the same year that we did, 2012. If you guys follow Snowflake at all, there is substantial backing from a number of venture capitalists within Snowflake. It's up close to $1 billion now overall. So it's one of those companies that pretty much hits every top 10 list from a technology perspective. What I've liked, and what David and I were talking about a while ago, is that you look at some of the cloud solutions out there that are native to the cloud providers. Your BigQueries with Google, your Azure Data Warehouses with Microsoft, your Redshifts with AWS. Well, I kind of got to stay on a cloud, a particular cloud, to use those things. With Snowflake, just like David and I were talking about, maybe you're going to use AWS and Azure. Maybe you don't know what you're going to use. This type of solution that is cloud native, that gives you all that flexibility to run across multiple clouds, regardless of what that foundational cloud technology is, I think is really nice, where you don't have that lock-in. So you can see some of the scale that Snowflake operates at. It's pretty impressive, and I'm sure the Snowflake guys in here, maybe the employees and customers, maybe even a little bit out of date now, based on where you guys are and where you're going. So, what is Snowflake? So to me, and I'm not going to just read these slides, what I'd like to do is just give you a perspective. Again, coming from an environment, still work with in a lot of places that we hear over and over, guys, make this simpler. Why is this taking so long? Why do I have to put so many people on these things? Why can't I get the performance that I want, right, in other environments? To me, those are the types of things, the simplicity, this acceleration of value, the ability to have my Tableau or Power BI users simply get into an environment and actually do their work, get value out of the data that's getting loaded in. Loading any types of data into Snowflake. Maybe I've got OSI Pi data, maybe I've got SQL data sets, maybe I've got this, got that. I want to put everything into Snowflake, make it easier for my end users as a data delivery organization to be able to consume. To me, that's what Snowflake gives. And it's consumption-based. I do not have to put in a bunch of capital investment into this thing. So I was with Oracle for 10 years, and for those of you, probably everybody in this room has had one of us Oracle guys in front of you at some point asking you to, please, we got to do, a $2 million capital investment to make something happen. Snowflake's not that way. It is consumption-based. You, just like we're going to show you today, turn it off when you want to turn it off, use it and get charged when you want to use it, and that is what we hear from our customers over and over again. They're tired of large capital investments. Give me consumption-based. We're used to it on the personal side, right? If I want to buy a Netflix movie, I buy a Netflix movie. I don't have to do a bunch of other things and buy 25 that I'm going to buy one if I want, or subscribe to one, right? If I want to grab an Uber from here to downtown, I'm going to grab an Uber for that one ride. And so I think just personally, we're really used to this. We're also used to things being easy now. We're used to things being 1 or 2 clicks and not having to go through down to the command line interface to get things done. So to me, Snowflake is bringing a lot of the things that we enjoy with all the technology that's available to us personally, actually bringing that into the enterprise is my perspective on it. And I think on this next slide, I've probably hit on the vast majority of these. It is a comprehensive and complete SQL database. Hey, welcome. Good morning. Come on in. Grab Mike, if you can move my stuff there. Yeah. We're just getting kicked off, by the way. So comprehensive SQL database, anything that you guys need to do with your BI tools, your Power BIs, your Tableaus, your Spotfires, clicks, etc., you're going to be able to do within Snowflake. Very minimal management, meaning that I don't need an army of people to run this thing. It's actually being done and delivered as a software service by Snowflake. We already talked about this. What do you want to put into Snowflake? You determine that. You make it happen, and it's not something where you're limited to the types of data or the data sets that you can put in. And to me, the big one, I've worked with clients over the last few years prior to Snowflake where there was really a wall around their data warehouse, their data hub, their data lake, whatever you want to call that thing. Everybody has a different term for it. And there was only a few people. There were only a few people who could get access to that thing. Oh, our business users, no. You'll impact performance. No, this has been fixed, guys. This has been fixed. We'll show you that today. Data sharing, pay for what you use, consumption-based. These are some of the core tenets of Snowflake. Chris is going to go into architecturally what these things mean and how they can impact you. Next slide, Chris. So, with that, any questions on the overview? Who is Hashmap? Who is Snowflake? What's the general premise of the value that Snowflake is delivering? Anybody? Yeah, Dave.
Where did the name Snowflake come from?
Snowflake, guys, where did the name Snowflake come from?
I think it depends on what story you believe in.
Yeah.
A lot of them. But our founders are big skiers, and so they something to do with snow, and then of course the Snowflake schema, which actually doesn't really have anything to do with
And then they say, where does snow come from? Cloud.
Okay.
So there's a couple of them.
Here's those jokes now.
There's a couple of,
we heard it all when our LinkedIn update said you're moving to Snowflake, and people are like, what are you doing?
just hear of this, there's a lot of snow-based words.
Any other questions, just whether it's on logistics, facility, et cetera, or the format today and agenda today, before we get going with Chris? All right. So Chris Herrera with Hashmap, take us through diving into Snowflake.
All right. Yeah. So I was told I'm not allowed to move because I've got something recording me. So I've never presented while sitting, so this is going to be interesting. All right. So what is Snowflake and how is it different? I'm sure if you've had any experience with databases, it sounds like a lot of you have, you've kind of got your two models, your shared nothing, so your Hadoop, where you've got basically your compute and your data basically just shared across. If you want to add data, you add another node, that's compute and data. Then you've got the shared disk model where you have the compute cluster and then the shared data, and then your single cluster is what's going to do your compute, and then you've got the shared data somewhere. What Snowflake is kind of shifting a little bit is this idea of a multi-cluster shared data paradigm. And what that means is you still have the centralized data, however, you're not limited to that single compute cluster. And we're going to see in a little bit why that makes a huge difference, especially when you're trying to do some of the things like Kelly talked about, getting your BI users in there, being able to do data loads, being able to do real-time updates via Snowpipe without impacting anybody's access to the data. So let's take a look at kind of how this is achieved, and I'm actually just going to jump forward here. So when you look at Snowflake, this is a cloud-native warehouse. It's important to remember that. This isn't something that you're going to install on-prem. This is something that you're going to have instantiated. If you've already gone through the free trial, you already selected your cloud and done your sign up, you'll see that you have two choices, Azure and AWS right now. And really, that doesn't mean that your company needs to be in Azure or AWS. That just means that's where Snowflake is. If you don't use Azure or AWS, you're just kind of there in Snowflake, and you don't really have to care outside of if you're going to do external stages, and we'll talk about that in a little bit. The cloud services layer, this is what actually provides kind of the tenancy for Snowflake. This is not the thing that you pay for. This is just the thing that makes Snowflake work. So essentially, this is kind of where you get into your data. You'll see you have your various connectors. There's a Python driver, there's ODBC connectors, there's JDBC connectors, and we'll show a little bit about that and how you can connect to it. And then on top of that, there's metadata managers and optimizers. So if you come from the Hadoop world, this is akin to like a name node type deal. And then you've got a virtual warehouse. So I want to stop here and explain what, yes?
I don't know if this is appropriate timing, but you had said that I could choose Azure or Amazon.
Mm-hmm.
Is this appropriate time to ask if there's cost differences or performance differences, depending on where the rest of my stuff is?
There's no...
Do I get faster performance if my stuff's in Azure and I choose Azure? I guess those are questions that we could save for another day.
So, well, we're going to talk about that in a little bit, but just to briefly answer, if you're using external stages, for example, Azure Blob Storage, you are going to inherently have a little bit faster copy command results if you're in Azure and you run it in Azure, just because you're not transiting the network. However, in terms of performance, cost, speed, that's across the board, it's going to be the same. All right, so just to quickly explain the terminology warehouse, because some people get a little bit tripped up on this. Warehouse actually doesn't hold any data. Warehouse is the compute. The data sits in that persistent data store that underlies the thing. So in AWS, that would be S3. In Azure, that would be blob storage. But the warehouse is actually compute. And this will make a lot more sense once we get to the hands-on lab portion. You can have multiple warehouses. And you'll notice here that you've got this, the little animation here. What that's showing is, let's say that I've got my virtual warehouse I've created. Again, we're going to show you what that is. And in this case, I've got a setup of a warehouse of a medium cluster. This medium cluster can horizontally scale and vertically scale. What I mean by vertically scaling, so this is traditional scaling in terms of Snowflake has defined t-shirt sizes. You don't really have to be concerned with, okay, this cluster has 512 gigs of RAM and 128 processors and whatever. You choose extra small, small, medium, large, up to 4XL. And that's your vertical scaling. You can scale while a query is running. You can scale before a query, after a query. It doesn't really matter. It's a SQL command. And you'll see it with doing it in one line. Now, that's good for when you want to achieve query performance. So if I want my query to run faster, I get a bigger machine. I get a bigger cluster. The idea is that it does scale linearly as you do increase that machine size. So if you had a query that was running at 1 minute, you double that machine size, you basically cuts down to about 30 seconds. That's the idea behind it. Now, that's great for query performance, but now let's say that I want to have 150 different people accessing the data at the same time. That's the horizontal scalability. And we're going to talk about how the cluster kind of auto scales and then shrinks back down when you're not using it as well. So it does scale in both directions, and that is the warehouse. Additionally, there is caching. We're going to talk about how that works and why it's pretty cool. And then also some considerations that you'll have when you're scaling out and scaling in again. And do feel free to ask me any questions. Just raise your hand. I'll stop. I don't want to kill you with PowerPoint. All right. So here is, so the idea behind multi-cluster warehouses. You'll see this a lot in Snowflake material. You'll see this a lot in the documentation, which, by the way, we're going to take a look at the documentation. It is fantastic. In this case, you see that we've got 3 virtual warehouses. So in this scenario, I might have a virtual warehouse that is responsible for being the portion at which I'm doing an ETL job. Let's say that I've got Talend, Fivetran, some ETL solution that's going to load data into my warehouse, but I don't want to affect, let's say, I'm loading this data because it has to be loaded now, but it's the middle of the day. I got guys who are actually doing analysis on this data. I don't want to impact them. I can spin up another warehouse independent of these other guys. The concurrency, the data concurrency is it's quote unquote unlimited, theoretically unlimited, just based on the persistent storage that is provided by the cloud provider. So that's the idea behind multi-cluster warehouses. It just means that you can have multiple different clusters of multiple different sizes with multiple instances of those clusters running at any given time. And you can authorize people to certain clusters. You can authorize people to certain tables. So basically, there's a very nice RBAC or role-based authentication system in place. So again, we're going to take a look at that when we get to the hands-on lab. All right, a quick note on Snowpipe. So this is another one of the snow-related words. So Snowpipe is for when you want to copy data from an external stage repeatedly. So let's say I have an S3 bucket, I have an Azure blob storage, I've got something where I'm going to be dumping files, and I don't want to be running that copy command either, orchestrated through Control-M or something like that. I just want it to just say, load this data every 15 minutes, purge the data when you're done with it. That's Snowpipe. It's just going to get that data in from your external stages as it shows up. Now, I want to be clear about one thing. Snowflake is not an ETL tool. It is a warehouse. So it'll copy in data that has been put there by an ETL tool, or you've got some output that outputs as CSV. We'll look at the different ways that you can load data in, but some people get a little confused. Snowpipe is not an ETL tool. It's just a way to move data in from a stage. All right, so let's take a look at and dive down a little bit into this multi-cluster warehouse scenario. It's easier when I get all the way to the end there. So in this scenario, we've got this Snowflake. And again, I want to point out that Snowflake is a schema. You don't have to worry about that. Snowflake is actually schema agnostic, so star, Snowflake doesn't really matter. The idea behind Snowflake was that they wanted to solve the problem of basically unbounded performance, pay-as-you-go, and concurrent access with native SQL access. So what that means is providing a SQL API to end users. It's not something like, for example, if you have HBase, that you have to put Phoenix on top of it to actually get SQL access to the Thrift API that sits behind it. This is native SQL. In fact, there's no other way to communicate with Snowflake. You do everything, create users, create warehouses, create resource monitors. You do all of that through SQL. And we're going to take a look at that in the hands-on lab. So in this scenario, you've got batch ETL services that are occurring in, let's say, a medium cluster. You've got ad hoc users who are just throwing queries at the system, and you've got a horizontally scaled extra large system for them. You've got a data scientist who's basically potentially created a clone, and we'll talk about zero-copy cloning in a second. And then you've got test dev users who are potentially using a clone as well. Workloads in this scenario don't compete with each other because you're talking about isolated compute instances. These are those warehouses that I spoke of earlier. So you've got your one database and you've got your multiple compute instances so that everybody's seeing the same version of the truth. Snowflake is ACID compliant. It does have the notion of transactionalities across the warehouse, and that's because of its shared data, this shared persistent storage that it does use. So you don't have to worry about one person in one cluster seeing an old version of the data. You can create situations like that if you desire by creating clones of tables and things of that nature. And again, we're going to talk about zero-copy cloning in a separate situation. Now, in this scenario, you'll see that metadata is off to the right. Now, remember, metadata was sitting in that cloud services layer. It's pretty nice because essentially what you're going to do is you're going to be able to hit that for any metadata queries and never actually have to instantiate your warehouse. That means that's basically a free query for you. All right, so just a note on some file formats that Snowflake can natively load. We've got JSON, Avro, XML, Parquet, and ORC. Essentially, they come in and you store them into a database. You can natively query JSON data just by loading it into a table that has one column that's a varchar column. You load in that JSON, and we'll see how you can query the individual nodes and also flatten that view and, let's say, join it with a dimensions table so that a BI user gets easy access to this data as well and doesn't really have to understand the JSON structure behind it. So these are built-in capabilities of Snowflake. And again, not an ETL tool. You're going to want to have this JSON formatted beforehand for what you want to do, but it does natively have that capability. And then, aside from that, there's all these other connectors that exist. So we're going to be using Fivetran today. I'm going to do a little demo. Fivetran being a SaaS-based ETL solution. I'm going to pull in some Salesforce data using Fivetran into Snowflake. But Talent, Informatica, Excel, Power BI, Python, Snowflake made a really nice open source Spark connector that is actually used in Databricks, which is the managed services offering of Spark in Azure and AWS, which makes it extremely easy to integrate the two. If you want to do some data science, if you want to do some more complex mathematics before you load the data in to allow your data scientists to get access to that. And then very easy integrations with things like Tableau, Looker, for your more exploratory data science work. All right, so what do you get? This is more Kelly's type slide, but the idea behind this is you don't have any infrastructure to manage. You don't worry about the EC2 instances that are sitting below. You're never going to be asked about what size VM do I need? Is this a D class? Is this, you don't have to worry about that. You don't need tuning. There's very little optimization. There are a few little things here and there that'll make you run fast, but not as fast as you could. But for the most part, it is pretty ready to go. You don't really have any indexing that you have to worry about. You don't worry about storage. In the slide that Kelly presented earlier with some of the metrics, there's a client with several petabytes of data, and there's a single table with, I think it was 64 trillion rows or something. So you don't really have to worry about partitioning, vacuuming, no sorting, no manual backups. All of this is handled for you. So I want to actually stick on the manual backups for a second. For those of you who are concerned about DR or HA, the way that Snowflake works is because it's got that shared persistence layer using either Azure Blob Storage or S3, the data will be available no matter what happens. So the cloud services layer, when you set up an account, let me start back. When you set up an account, you set up an account in a region. So if you're familiar with AWS, a region is a geographical area, and within that region you have different availability zones. Microsoft has the same thing. These availability zones are separated across this region so that if a flood takes out one, you're guaranteed that the other one is up. That's the idea behind availability zones. Now, the cloud services layer is spread across this, and then the persistent storage is spread across this as well. So let's say a flood takes out one of the data centers. You don't have to clone that data over. There's not like a 4-hour downtime or 10-hour or 12-hour downtime when you're going from one AZ to another. The data's there, it's in S3. You're spinning up another warehouse, and you're ready to go. And that is a matter of seconds. And your users didn't even notice a thing. So DR HA is available for you kind of out of the box. For data durability, both Azure and AWS provide that 11 nines durability. So basically, you're not going to lose your data. So let's talk about the all-in-one big data system. The idea behind this is that Snowflake can handle structured, so your CSV, your tabular data, or your semi-structured data. Semi-structured data being your JSONs, things of that nature. You'll notice there's not unstructured data. I do get this question a lot. That's not a thing where you're going to load. This isn't kind of your wide open data lake, your voice, your video, things like that. No. Once you process that data somewhere else and you get some actual values that you want to process out of that, great. But this is not the place for your unstructured data. Semi-structured data, your JSONs, your Avros, XML, Parquet, sure. And then your structured data. So we're going to be loading today during our hands-on workshop an example with JSON and then a different example with CSV. So you'll be able to see kind of the difference there and how you work with it. So the nice thing about this is, like Kelly mentioned, we do a lot of work with kind of your traditional big data platforms as well. One of the major complaints is the skill set that comes with Hive, LLAP, being able to optimize your queries, understanding the HBase backend, understanding how you set goalposts and Phoenix optimizations and all that fun stuff. This is standard ANSI SQL with ACID compliance. If you've used a database, you kind of understand how to use this. You do have UDFs that can be defined via JavaScript, SQL. You can have stored procedures. So the skill set is not such a huge burden to get onboarded into this ecosystem. Additionally, there is, because of the large number of connectors and then the standard set of connectors that they have through ODBC adapters, JDBC adapters, the Python drivers, the Spark context, you are basically ready to run in a majority of the tools that you're probably already using. From the automatic data replication, the HADR, like we talked about, the geo redundancy, from the availability standpoint, you are already taken care of. You don't have to worry about that. And then you've got security as well. So HIPAA compliance, PCI compliance, that's all sorted out in Snowflake as well. And then the actual physical security is relegated down to the cloud provider themselves, and they've got all of their certifications as well. Now, we're going to talk about fast elasticity. This is the consumption-based model that Kelly was talking about. So in this scenario, let's say that you're coming from a traditional kind of paradigm where you're doing your ETL and your processing, and you probably want to do this at night, not to impact your users. And let's just say that you have these jobs running anyway because you're pulling data from another database and you don't want that database to be impacted. Fair enough. So what does this look like? What you're seeing here is basically the cluster auto-scaling. So in the areas where you're not seeing any of this kind of bluish, that means that the warehouse is not actually running. You're not paying credits for that warehouse. And then at night, it'll spin up. Now, let's say that you've got your SQL analysts, your BI guys, and they only just really want to use it at one specific hour during the day. It spins up and spins back down. And the way that this actually happens is because you've got these features of auto suspend and auto resume. And we're going to look how to set those when you set up a warehouse within Snowflake. So basically, auto suspend means after a threshold of time that is definable, if a user hasn't gone to a dashboard, submitted a query, done something like that, that warehouse is going to spin down. It's going to be available, but it's going to spin down until the next query comes in, and that's what auto resume is. As soon as the next query comes in, it spins back up, and that query is going to be completed. Nobody ever knew it was down. Now, in the scenario where you have an auto-scaling multi-cluster, this is your reporting use case, the third one down here. This is where you have an auto-scaling multi-cluster, meaning I've got my medium, and then I've got a bunch of users, and they're coming online, and so a second medium was picked up, and now the queries are being load balanced between the two warehouses. And then as that nighttime comes in, that activity will drop off again. And then you've got your ad hoc analytics that are going to occur whenever. So in this scenario, you could have defined essentially 4 different warehouses. The first one would have been a small warehouse that has a minimum of 1 and a maximum of 2. In your SQL BI analyst, you've got a large cluster. In your reporting, you've got a medium that scales up to a 2, and then you've got a medium for your ad hoc analytics. And then, again, absolutely. It is. Because you're not actually spinning up EC2 instances, and you're not spinning it down. There's shared instances that are spinning on the back end that's managed by the cloud services, and you'll see how quick it is. It's basically, I execute query, light turns green, query returns in a matter of seconds.
So it's Snowflake managed.
It's Snowflake managed. It's not like when I turn on a cluster that this cluster has to boot up somewhere in the back end. There's a set of spinning machines that Snowflake is managing on the back end.
Right. So I mean, are you giving up the virtual space when this is spun down, or are you?
So we're going to talk. There are some trade-offs. So when you give up this virtual space, really the only thing you have to be worried about is the cache that warehouse was containing, because that will be flushed. So if somebody executes the same query and it was a 10-minute query, it's going to take 10 minutes to repopulate. But when you give up that space, it's not like you're going to be in space contention again with somebody else. That is managed kind of by the elasticity of the compute that the cloud provider offers.
So spin-up's not instantaneous, but we're talking single-digit seconds here.
Yeah, we're talking very, very low.
So, I'd like to touch on the cache. The BI tool that BMC uses is MicroStrategy. We're very, very cache heavy and queue heavy.
Yep.
So we have our data warehouse. We generally do twice a day or once a day loads. Our loads are done, we load up terabytes of cubes.
Mm-hmm.
So people don't hit it easy to keep currency down.
Mm.
Limitations on limit either. So I want to use cache for a good amount, 30% of my reporting. They hit cache, they don't have to go ask for it.
Mhm.
So I know you said, how do I keep cache up? And does that cost me compute time as the cache is up?
Yes, because the warehouse has to be available for that cache to be there. There's cache pre-warmings and things that you can do when clusters spin up, but that extends the time that it takes for your cluster to be there.
So is it different, the cache is up, right, but it's not being accessed, right? Is it different cost as you, is there, the timer increases as more people hit the cache, or there's just a standard cost for the cache to be up?
The cost is for the cluster. So let's say that you had a cluster, you had a large cluster, and you only had the one instance of that large cluster. So that cache is going to be there for the period of time that you say that cache should be there. If it's 24 hours, 24 hours, whatever the result set you want. Now, the thing is, let's say that large auto-scales to 2 larges, and then the workload goes down, and you're back down to the 1 large. Those caches are held on those independent warehouses. So what ends up happening is that you're going to end up having, if there was a query done on this one that's no longer here, this cluster that's no longer here, and you go back to your original one, you're going to have that cache is going to be rehydrated once you execute that same query. But that cache will be resident as long as that long as that warehouse is up. Does that make sense?
When you spin down, does it spin down to 0? The cluster is
Yeah,
gone.
you can set it to never spin down to 0, or you can set it to spin down to 0. That's that auto suspend that we'll look at. If you don't set auto suspend, you can always have one running for forever, but yeah. And then
Just want to be clear, right? There's 3 types of caches, but the 2 you're most interested in are the tape caches, which live and die with the virtual warehouse.
Yeah.
Results set caches, which persist, right, for 24 hours as long as they're being touched. Even if the warehouse goes down and comes back up, if another user runs out of that frame 3, results set cache will be there.
yes, good point. So specifically, sorry, I forgot your name. The BMC, Jeff. That was a good point. I wanted I wasn't very clear on this. There are different. So if you're looking at just result set caching, your warehouse doesn't actually have to be up for that. Yeah, sorry. The warehouse itself is going to cache the tables so that it doesn't have to do remote I/O and things like that. For the result sets, that's actually handled in the cloud services layer, and that's that caching. So if I'm making a query that hits the cache, that cluster might actually never spin up if it's suspended. It's pretty cool, actually.
Yeah, that's what I said is, they have a lot of reporting that just hits these cubes from MicroStrategy.
Yeah.
And it sounds like it's kind of it's wrong, freebie for me, but it's Snowflake, because I can keep the cache there. It's okay, free's good.
Free's good. So I'll show you really quick where it sits. So, sorry, what was the question? Power BI, yes. By finance. It's kind of hard to see with the resolution. It's the yellow box. But I just want to quickly just not to harp on it, but it is an important point. That cloud services layer runs regardless of whether or not you have an active warehouse. That's just a Snowflake managed bit. That's where the result set caching occurs. The cache that you see inside of the warehouse here, that's the table cache. That's to reduce the remote I/O that you have to do to the underlying persistent store. I just wanted to be triple clear on that.
But there's a limitation of how much result set cache. There's a cost for how much you want.
So the result set cache, I think as long as you touch it within 24 hours, it's going to stay there. But
Or unless the underlying data set changes.
yeah, it'll if the underlying it will go ahead and expire that if the underlying data set changes.
So the storage, is that storage specific to Snowflake, or is it?
When you're talking about the persistent data store?
Yeah.
Yeah, the persistent data store is the data that is stored within that persistent data store, you don't get raw access. Like you can't get to that S3 bucket. That's a Snowflake. That's Snowflake managed.
Once it's in there, we should be going directly.
We're going to talk about external stages. That's where kind of the data that you have. That's your, let's say, S3 bucket. That's your blob store that you're going to get the data out of and put into Snowflake. But once that data goes into the persistent store, you don't ever touch that. You don't have to manage that. That's a Snowflake managed thing.
But if we didn't want to put it with Snowflake and we wanted to access it from Snowflake, that can't be done, right?
You would have to load the data into Snowflake. Yes. So Snowflake has the way that you access data in Snowflake is through tables. It's not going to be like HDFS where you just plop a file and you can get access back down to that raw file if you wanted to.
I was thinking like Redshift, where you can access data in S3 or access data that's inside Redshift, which was S3 anyway, but
Yeah.
No, you also load data into that.
You load the data. So in order to access data in Snowflake, you run it through a copy command. You run it through Snowpipe. Yeah.
And you can copy it into a table, of course,
Mm-hmm.
but you can copy it as a JSON file as well.
Yes, so it has native support for JSON, so I can store a JSON document in a cell, basically, in several rows. Basically, I can have a schema that, and I'm gonna show you that. Basically, just have a schema that's just a JSON document, and I'll be able to query the individual nodes. I can flatten that as well to join with the dimensions table.
Column type.
Yeah, it's just a column type variant. Yeah. All right. Any other questions? Cool. All right, back to where. There we go. A quick note on data sharing. So this is just kind of a really, really nice feature where, because it's in the cloud and it's available, it makes it really easy to share your data with somebody else. Let's say you have a joint venture partner, you've got some other partner that needs to get access to this data. You can create reader accounts, and you can grant down to row level access for these reader accounts to be able to get to a warehouse. Now, in this case, the consumer doesn't actually have to pay for this. It's down to the provider that pays for this. But you can create warehouses that they're specifically entitled to, and you can create row level entitlements so that I can share data with my partner, with a joint venture, with a supplier, whatever I need to do, right? So that's about as easy as it gets. We'll look at creating reader accounts and what that entails and kind of how that works. But yeah.
So sharing using some tool or using the
Snowflake. So they'll get a Snowflake login. You'll be able to access the warehouse. They can use the same things, the ODBC, JDBC, Python drivers, whatever, access the data. So instead of exporting a PDF or a Spotfire report, you're just able to just say, here's a warehouse, go nuts. So zero copy data cloning. So this is actually very cool. I'm a huge fan of this. The reason is because let's say that I have, actually I'm going to go through a bunch of scenarios because there's a bunch of scenarios where this is pretty awesome. So I've got my production data store and I want to create a clone for a problem where, let's say I had a price list, and for whatever reason the price list was artificially 25% high for all of the values. I can create a clone. Now, as soon as I create a clone, it doesn't actually copy the data. So I'm not paying for extra data storage or anything like that. It's literally, if you think about it, it's just giving you a pointer to the data. The only thing that's actually written are any modifications you do to that data store, or to that data set, I should say. And then when you write that back, you can write that back to the production, and actually no data has moved. So you get access to the clone very, very, very quickly. It's not like it has to physically copy any data over. So I don't have to be worried about cloning my 22 terabyte database. I can clone it. It won't have actually moved the data. I'll just have a new logical database that I can then access. And you'll see how we do that in the hands-on workshop. But this is very useful for dev test scenarios where I wanted to add some features. I wanted to do some schema modifications. I wanted to completely destroy my production database without destroying my production database. It's just, all I have to do is execute a clone command through SQL, and I'm up and running. You can, in the scenario where you have to have a backup of tables, you have to have versions of tables. We're going to look at time travel. But specifically for cloning, if you have to keep this resident for a period of time for any compliance, internal or regulatory compliance, you can do that as well.
So what are the one or two like limitations?
So one of the considerations you have to make is entitlements. Entitlements don't come over with clones. So generally, if you clone, you're going to clone for a specific purpose. Like I'm going to give this to my dev team to do something. Those entitlements are going to be separate anyway. But that is something that does trip people up. I would say that's a big one.
Now, if the underlying database changes, excuse me, not database, but if you clone a table,
Yeah.
and the original table changes a lot, I guess.
You can re-up the changes. You can bring in those changes, but that's in control by the person who's authorized on that clone. You can then refresh the changes whenever you need to. All right, time travel. So time travel is awesome. The best way that I can explain time travel is through the undrop command. If you've ever dropped a table accidentally and you wish there was undrop, that's how this works. So the retention period is managed by the admin. By default, it's 1 day. So if you try to undrop it 1 day and 1 minute, I'm very sorry for you. You lost that. But you can store 90 days, up to 90 days for the retention period. But even cooler than that, you can actually do queries in history. So I can execute a query as if this was the table up to a day ago. And I'll show you how to make offset queries in the hands-on lab. But basically, my favorite is the undrop table. I've dropped tables before. It's bad. So, yep, we're going to take a look at how that works. But it's also very cool to be able to query in history. Yeah. So this is a good example of a granular data access with time travel. So basically, it's that at operator that we're going to use, and I say the timestamp. I can either say a timestamp or I can do an offset, and then yeah, I'll get the information for that line number 4, as it was in February 1st of 2018 at 5 o'clock, basically. So. Note on security. So authentication. There is embedded. Yes, sorry.
Is there a performance? I would assume that there's a performance increase if I query for 1 second ago, and then if I query for now, due to avoiding the concurrency constraints of ACID. So do I get any performance by specifying a time for my query?
Not really, no. I mean, so first of all, I guess one of the things to keep in mind is if you're loading data, first of all, you don't load data into Snowflake through using like a barrage of insert statements. You're going to do a bulk load. The performance of Snowflake just tanks if you just barrage it with insert statements. So when you talk about querying for the most up-to-date data, typically querying for select star you're not going to see a major amount of difference between select star and select star from 1 second ago. Does that kind of make sense? If I understood your question correctly. You're not going second by second. This isn't like a historian or something like that. Yeah.
That makes sense.
So we should not use this for any transactional application.
So when you're talking about a warehouse for analysis or things like that, you wouldn't use this for like an OLTP solution, right? What I would suggest is, let's say that you have an OT, an operational technology system, an OSI soft PI, Canary, transaction processing system like a sales order system or something like that, point of sale system. Getting that data either through Kinesis, Confluent, whatever, dumping it into S3, creating a file from that and doing a bulk load through Snowpipe is automated and it's efficient. And generally it achieves whatever you're trying to achieve. Most people aren't going to their warehouse for, the last transactional data, right? So, yes?
Does anybody load directly from, let's say, for example, if you're generating the files on the Unix environment and you would like to load directly into the database, can we do that?
So there's this really awesome CLI tool called SnowSQL, and that's what I would use. It's really, really nice. So if you've ever used SQLine or if you've used command line SQL clients before, somebody looked at those and said, how can we make it better? And that's what SnowSQL was. Honestly, auto-completion is huge, and I love it, and that's what SnowSQL gives me. So, but yes, that's what I would do. So let's say, for example, I had a file that was being generated on my Unix box. I would just use SnowSQL to go ahead and load that data.
Instead of copying it to S3 somewhere.
Instead of creating an external stage. The other thing you can do is create an internal stage. Let's say you don't have S3, you don't have blob storage. Snowflake provides internal stages that basically just leverage the underlying. You pay for that. I mean, you pay for the storage, but you can create an internal stage. Let's say you don't use S3 and you don't use Azure blob storage, then you just create an internal stage and load it that way. All right. So I spoke very quickly about it, and I'm going to show you a little bit. It's not going to be really a master class in role-based access for Snowflake, but I'll show you a little bit about granting roles in Snowflake, and then how you can provide privileges on objects and actions. All data in Snowflake is encrypted. There's no way to store unencrypted data in Snowflake. All the data in transit is encrypted, and then there's external validation, like I said, HIPAA, PCI, and then there's the physical security that is provided by the cloud provider itself. So a note on a few case studies. These are the Snowflake provided case studies that are awesome. I'm going to dig into the ones that I have actual experience with. So Devon Energy. In this scenario, they were struggling with how to make use of their data. They were using ADLS as a kind of a data lake. And the problem with that is they had this awesome data lake that nobody could get access to, because once you actually got access to the data, you had to understand how to read the formats, you had to understand how the data was organized, you had to kind of assume a lot of things. They wanted to be able to have a consumption-based model because they didn't want to have a cluster that was sitting there spun up all the time for their guys who were doing ad hoc queries, once a day, once every couple of days, things like that. So what we helped them do was load data into Snowflake from their multiple OT systems, from their IT systems, their ERP data, their on-prem EDW data, their OSIsoft Pi data, so a bunch of different types of data into Snowflake, and create multiple warehouses depending on the group that was using it. So in this case, we've managed to kind of, yes? So again, a warehouse in Snowflake terms is the compute cluster. So we created different compute clusters for the different groups. So we had the cluster for the IT group that was responsible for doing kind of the daily loads from OSIsoft Pi. We had the cluster for the BI group that was just doing their ad hoc queries, and that one spun up and spun down as it needed to. So it was just a way to kind of separate them so that nobody had any performance impacts on the actual data access. Yes. So basically, well, yes. So the answer is yes. There's a bunch of different ways to handle the roles and how people should have their default cluster, how default clusters have access to specific things. It really, you can authorize entities, essentially, to have all different types of access. And the way that you structure your roles within Snowflake is dependent really on your use case and how you want to use it. It really does provide you with the flexibility that you need to match your security compliance, to match whatever your business case is, right? Because some people are going to have very different ways to access data. It is very, very flexible.
It does support schemas, right?
Oh, yeah. Yes, it does support schemas, absolutely. All right. The other thing was a substantial decrease in query times. The big thing there was we were battling a traditional big data cluster at the time, and we basically had 4 admins sitting there at any given time trying to keep that cluster running as appropriately as possible. And the problem is it was just as the data volume was increasing and we kept adding more nodes, the administration of it became more and more complex, and you ended up achieving negative utility pretty quickly. Here, we're able to throw a much larger cluster at it for a very small period of time and only pay for that time that we're using that warehouse. So that was a big improvement there. Now, in this case, we needed to basically take logs from consumer security devices and be able to provide back to the business team how people were using these security devices. So these were just like IP video cameras. It allowed them to do analytics on how often these devices were failing, how fast the batteries were failing, how well the signal was being received by the camera, things like that. In this case, all of the data was originally in a big data cluster in ORC files. It made it really easy to just kind of take those off from HDFS, put those into S3, and then load them from that stage. That was very, very quick. And in this case, we actually used Snowpipe to load the data in automatically. So as new files appear from the ETL tool, we're able to load that data and provide that view back to the client using Tableau very, very quickly.
So Tableau was on-prem or on the cloud?
In this case, it was on-prem. It was it was on-prem. And then there's an entire ecosystem built around Snowflake. This is one of the things that's really nice is the fact that it does work well with a lot of the tools that are out there, and then there's a lot of people who are able to help you with this should you need it.
I mean, this is for each one of these, how they connect the database, probably a JDBC connection or a connection.
Yeah,
It's
so
not like Snowflake is really integrated with this. It's just that.
you'll see what I mean by integration when I show you Fivetran and when I show you Tableau. It'll make sense a little bit more. What I'm going to do is I'm going to take you through the UI, get you familiar with kind of all the different words that I said earlier, and then it'll make a lot more sense for when we actually run through the hands-on demos. All right, so if you've signed up, this is the screen that you should see. You've probably already logged into it. I can't type in credentials and talk at the same time. It doesn't work. All right, so let's just take a quick look at kind of the different buttons and the important bits on this UI. So first thing I'm going to show you is this top right, the user profile. There's a very important button here that confuses people sometimes, which is switch role. So when you created your trial account, you are the account admin. So when you log in, you will either be sysadmin or account admin. It's been a while since I've done it. But if you need to do anything that requires creating users, creating roles, doing those types of things, that's going to be done as the account admin. So you'll see here, an easy way to tell is I've got this account button here. And through the account, I can do things like see my billing, my usage, how many credits I've used, my users, resource monitors, sessions, all those types of things. When I switch my role to sysadmin, I'm going to lose that information, and I'm going to now only have access to sysadmin type operations, creating databases, creating warehouses, things of that nature. And I can manage these roles, and I can grant people access to things. I can manage the roles as account admin, but anybody who has grant authority on objects is allowed to grant permissions on individual tables, schemas, warehouses, things of that nature. And you're able to grant the type of operation that they can do. And we're going to take a look at that a little bit later. I'm not going to delve into it just now, because I'm just going to show you the bits of the UI.
May I ask you a question?
Sure.
Particularly in an organization, who actually performs that role? The developer does it, or
Who performs the account admin role, sir? It really depends on the organization. Very rarely have I seen a developer do it for anything other than kind of a dev kind of warehouse. In the case of an organization, you generally have owners for specific parts of the data, and they would handle that.
Is there APIs so you can do it?
Yes. So all of this is driven through the SQL API, and what we're actually going to run through today is just SQL, and you'll see how to create roles and do all of that through SQL. So the only API is SQL. All right, so databases. Databases shows you basically what you would expect to see. So you should have Snowflake sample data in your trial account. So if you click on that, you'll be able to see your different tables, and you can see kind of the catalog sales is essentially 93 or 9.3 terabytes. I can't really see. You've got store sales, which is 10.9 terabytes. You can get some basic information on your tables. You can also look at any views that are available. Schemas, so you had a question about if schemas are there. They definitely are there. And then stages and file formats. So we're going to talk about that and what that means a little bit more. But stages and file formats are held as a part of the database itself. So if I create a database, my stages and my schemas are, or my stages and my file formats are part of that. Moving on to warehouses. Again, this is my compute. So you'll see I have no warehouses here. That's just to show you how we're going to create a warehouse. But if I wanted to create one, I just click create and I'll go through that in just a second. And then worksheets. So this kind of shows you how through the UI you interact with Snowflake. So everything's basically done through these SQL queries. In this example, I'm using the role of account admin to create a role for Fivetran, which is my ETL tool that I'm going to show later. And then I'm going to grant that role Fivetran to sysadmin, basically. And then from there, I'm going to switch back to sysadmin and create my tables. You generally want to do all of your table manipulation, things like that. You don't want to do that as the account admin. That's really more as a good practice. Just don't do that as the account admin. You want to do that as a sysadmin. And then you can see here I'm creating a user in a very secure way where I'm showing the password to everybody. And then that's essentially how you interact with it. So you have multiple workbooks. You can you click on this little down arrow here. You can open tutorials. You can open worksheets. You can load a script. In this case, what I'm going to do is I showed that shortened URL earlier. I'm going to show you really quick what a resource monitor is. Resource monitors are important because they monitor your usage of the cluster.
Hey, Chris.
Yeah.
From back here, the screen, when you go into Snowflake's a little bit smaller. Are you able to blow it up a little bit so that we can see a little bit better? You may have to move around.
Start from up here as well.
Yeah. There you go. An old guy like me
Good?
can see it now. Yeah. I like it. Is that helpful?
All right.
If you can move that past 50 like me, you gotta give me a little extra magnification.
All right. So anyway, now that everybody can see, it's more helpful. Again, the Worksheets tab is where you're going to do the majority of your work in. One of the things I want to point out about Worksheets, it does trip people up. This little context drop down right here. Worksheets can run as different roles. So if you have a worksheet that requires account admin, you're using the account admin role, you need to make sure that you change the context. Just because I change it up here doesn't mean my worksheet changed context. Also, I choose my warehouse, my database, and my schema in here as well. I can do that through everything except for the role I can do in the worksheet itself. I can say use schema, I can say use those different types of things. But the context is important for when you're actually utilizing it's important for some of the sheets that we're going to be using today. So for example, this resource monitor. You'll remember that resource monitor was available when I was an account admin. So if I jump back over, because you might not have seen it, when I click on account, I've got these resource monitors. So resource monitors, I've already got one set up here. Basically, when I create a resource monitor, I'm saying suspend and notify when I have a percentage of credit. So I set the number of credits. Now I can monitor this at a warehouse level or at an account level. An account is within a single region. That's all of the warehouses, all of the databases running within that account, or I can monitor a specific warehouse, and I can have a number of different monitors that either notify me or take action. So in this case, suspend and notify will suspend the workloads that are occurring and also email me. Suspend immediately if let's say I achieve 95%. I want to shut everything down. I don't care if there's active queries or anything like that. I just want to shut it down. So what we're going to do is you can either create it through the UI, but there's this nice little button down here. If you don't really know kind of how to handcraft the SQL, if I come in here and say demo monitor, and I say my credit quota is 200, and I want to notify and suspend when it's, let's call it 85, and I want to do the suspend immediately when it's 95. I can hit show SQL, and it'll show me the SQL I need to execute. So if I wanted to automate this later, if I wanted to throw this in a workbook, I could do that. I've already got one set up, so I'm Just going to leave that one there. The resource monitor? It's for, so if I set it up for an account, an account in Snowflake is the overall account. That's the, like in your trial, that's what you set up. That's the entire environment in which you're operating. So that's you have an account, the account is per region, that's the entire account. You can also do it per warehouse. Let's say that my dev test team is allowed to use 50 credits. Then I can set up on their warehouse, shut it down when they get to 50 credits. You know, I've got this crazy data scientist over here who likes to use 4 XLs. Then I'm going to allow him to do 100 credits, and then after he burns that up, he's not allowed to play anymore.
How do you take credits in dollars?
So by default, and the Snowflake people can keep me honest here, I think it's about 1 credit to $2. Is that roughly equivalent?
Depends on the edition of Snowflake.
Right. So, yeah, so in the trial, we're using the Enterprise Edition. So that's roughly what it equates to. The other thing is the History tab. So the History tab's pretty neat. The History tab shows me all queries that have been run. So I see user Randy has been doing a lot of stuff. Thanks, Randy. So I might have to set up a resource monitor just for Randy's warehouse. Over here, I can see basically any query. I can click on the query ID, and I can see that, I can see that there's an access control error. So I can see the queries, I can see the profiles. I can't execute them as they're not my queries, but I can actually, internet's kind of slow. I think when we all log on to the conference at the same time. No, it's generally pretty fast. Yep. There we go. Come on, Internet. There we go. Okay. So let's just do a quick run through of, I'm going to go ahead and run through the first workbook that I'm going to have you guys do. I'm just going to run through it, show you how I'm going to do it, and then I'm going to have all of you guys do it after me so that you'll get a feel as we go through the other workbooks, you'll be a little more confident. So I've already got it loaded into my worksheet. So let me open it up. So this is going to use, we're not going to load any data in the first one. We're just going to get comfortable with using a workbook and interacting with a workbook. We're going to use the sample data, just data from the sample data set that's already included in the trial. So the first thing I'm going to do, you'll notice here my context, I've got account admin. I'm going to go ahead and change that to sysadmin because I'm not really doing anything that requires any role changes or anything like that. I'm going to show you what's going to happen when I don't do this first thing. So I'm going to go ahead and use this Snowflake data. You'll see, so when it's yellow, you can like mouse over this guy and see what it took in compilation. So compilation is just compiling the query that you did, and then the actual execution is the blue part. So overall, this was, it should be, it's pretty fast. Now, what I'm going to do is I'm going to go ahead and execute this, but you'll remember I don't have a warehouse right now. This is super hard to do when I'm so zoomed in. All right, so I'm going to run this query, and what has occurred right here is I've returned data. And the reason I've returned data and I have no warehouse is I'm actually hitting the cache. So you'll see I had no warehouse. I've run this query before and forgot to clear out the cache. So what I'm going to do right now is I'm going to, because I didn't get to demo what I wanted to. So now I'm telling it don't use the result set cache. Basically disable it for this session. A workbook runs within its own session. And now I'm going to run this again. And it should get mad at me. There we go. No active warehouse is selected in the current session. Select an active warehouse. So what I'm going to do is I'm going to go ahead and create a warehouse. I'm going to create it through the UI for this example, but in your example, it'll be through SQL. I just want to show you the different options that are available. The result set is query specific. So if I execute a query against a schema in a table, it's going to give me, if it's the same query, I'm going to get the same result back. Yep. Nope. All right. So this in zoom mode is quite challenging. I'm going to zoom out a little bit and see. All right. So here I'm going to just create a demo, compute demo. And by default, the size is extra large. Here, we're just going to use extra small. It'll show you how many credits per hour you're going to use. So I'm going to go extra small here for 1 credit per hour. You'll see that right now I've got minimum clusters and maximum clusters. So in this scenario, what's going to happen is the minimum number of clusters I'm going to have is going to be 1. So while this warehouse is active, it will have 1 instance of an extra small cluster available to the warehouse. Now, let's say that I get a whole bunch of queries going. It will spin up a second instance of the extra small cluster. You can't mix and match. I can't have like auto scale up to it. I can't have a small and then have a medium show up there too. It's going to be the same size. And then this is going to scale up. Now, let's say that I wanted maximum efficiency at all times when this thing is running. I could just set the minimum to 2 and the maximum to 2, and that would just run at max power all the time. But in my case, I am budget conscious, and I'm going to set 1. Yes?
Salesforce itself has some kind of a monitoring tool alerting customers saying that this zone is running slow versus not running slow, performance degradation, something like that.
So I've never seen anything like that. I mean, there's service status, but
Yeah, so everything we audit, right, so all the query history is query text, the performance of the environment, maintain 40 per year. You know it's going to query that. And then you can, in real time, query what you show in the history chat to see how things are performing at that point in time. With all the notifications you set like this for resource monitoring, so it shows you.
yeah. Yeah, but I think I know what you're talking about in Salesforce. There's nothing really equivalent to that that I've seen. Yeah. Yeah, there you go.
Can you set maximum clusters to the same number so it doesn't expand?
Yeah, absolutely. I could set 1, 1, and you'll just see that it's just 1.
So instead of adding more nodes to the cluster, you just create more clusters.
Yeah, exactly. Exactly. So 0 is suspended, and that's auto suspension. We'll talk about that in a second. That's actually the very next thing we're going to talk about. Auto suspend. So this is when the whole thing just goes away. It defaults to 10 minutes, and you'll see this very dangerous one down here called never. Never will never turn it off. So that crazy data scientist who creates 4 XLs and then never turns them off, that could happen. Now, things to be serious for a second, things that you want to think about. The table sets. So we're going to look at a query profile, and you're going to see kind of the percentage of time that's spent in remote disk I/O versus the time that's spent in actual processing. When you talk about that remote disk I/O, that's going. If you're dealing with large data sets, that's going to be a chunk of your query time, right? So when you talk about the warehouse cache, not the result set cache, which is handled in the cloud services layer, but the table cache that's held in the warehouse, that's going to be primarily what's responsible for reducing that remote disk I/O. And so as my warehouse, if I suspend my warehouse, that's gone, right? So I'm going to have to rehydrate that on the next query. So you're just going to want to have a business idea of, okay, so this warehouse is for these guys who generally query this. They need to have, I've got an SLA that they want to get this result in 1 minute or under 1 minute. So do I need to keep one spinning all the time? Or I should say this result. They need to execute a query, ad hoc queries on this table. That's probably the best way to say it, because otherwise you're getting it for the results at cache. But they need to execute ad hoc queries on this table. So I'm just going to have this one warehouse spinning all the time, so that I make sure that the remote disk I/O isn't a huge burden. Does that kind of make sense? But yes, the minimum cluster of 0 is basically suspended. Now there is auto resume. So auto resume is as soon as there's a query, as soon as a user logs, as soon as a user interacts with the data that is not in the result set cache, this cluster will come back up, auto resume, and it'll be subject to the same scaling policies that you set prior to this. And again, if you wanted to see what this looks like, this is what it looks like in SQL. You can toss in a workbook. That's what we're going to be doing here in a second. But I will actually just go ahead and take this. And I'm pretty happy with this. I'm going to finish. and you'll see that I have my cluster here. Now you'll see that my cluster started in the started state. There is a property to start it in the suspended state as well. Let's say I wanted to create a 4XL cluster, but the guy's not going to use it until next Tuesday. I could do that. Suspended state, not going to be billed for it. All right, so let's take a look at this little table here. At this point, you get most of the information you need on your demo cluster. And also when I go back to my worksheet, if I set the context for my warehouse to be the demo cluster I just created in the context of the admin. See, this is what happens when you create things is account admin. So what has happened is I now have to switch to account admin because I don't have it. I could grant myself access, but to be honest, that's going to take a little longer than I want to spend on this. So here, now I can actually run this query and I'll get a result back because I do have a warehouse cluster. So you'll see here that the yellow line, again, is computation, and the blue line is when it's actually executing the query. So this is an extra small. All right. It'll be done here pretty soon.
It doesn't have to compile every time, I take it.
Hmm?
It doesn't have to compile every time, right?
It does compile, but there is optimizations that don't mean that the compilation is going to take the same time all the time. So here we executed this in 31.22 seconds. You can see the result set that we got. Now, let's say that
So what are the size of the table?
So in this case, this table was one of the 1 terabyte, several terabyte tables. Now, in the case, so one thing I will show you is query profiling. So you can see the details of the query at any time. You can see kind of the results and the query that was done. And you can also access this through the history tab as well. You'll see here that 81% of the time was used in remote disk I/O. One of the things that I want to point out, and this is not a great query to visualize this on, but 250, this is tough. Snowflake does have column-wise and partition-wise pairing, so it only brings over the data that it actually needs. And I say partition, you don't manage a partition, Snowflake manages a partition, but it really optimizes what it needs to bring across. So if you saw the metric on that 64 trillion row table, it's not actually scanning 64 trillion rows. It's gonna scan the partitions that it has internally, and then it's also gonna scan for the columns. It is a columnar database. So that's the profile for this query. But now, what we should see is I'm going to, and I already showed you result set caching accidentally the first time, but I'm going to show it to you again just in case that was a little confusing. I'm going to run this query again. And this time, I'm actually going to take my warehouse, and I'm going to suspend this guy. So I don't have my warehouse running, and if I go into my worksheet, you'll see here so you'll see here that the little green dot went away. That means that my warehouse is not actively running right now. So what I'm going to do here is I'm going to go ahead and run this again. Oh, and I did something bad. What did I do? Oh, I know what I did. Haha. Semicolons. Bane of my existence. All right, so right now what's occurring is I'm compiling the query and it has started up again. Oh, this is what happens when I demo live. So I turned off the caching session-wide and I never turned it back on. So I'm going to go ahead and turn that guy back on right now. All right, I can now cache again. So I have to run this one more time. All right, this time, if I look at the query profile, you'll see query result reuse was 100%. I didn't have to go to anything. Now, in the case where I turn off result set caching, I will still reduce that remote disk I/O just due to the fact that the table's cached within the warehouse. But in this case, I suspended the warehouse, which means my cache went away. All right, so let's say, for example, that I'm going to go ahead and turn this guy off again, and I'm going to, so the last time it was a 30-second query. I'm going to go ahead and alter my warehouse to be a large size. So now my warehouse is large. You'll see here that there's a little L, if you can see that. It means it's large, and I'm going to run this guy again. And I'm still pulling from cache. Oh, no, I'm not. I'm just super fast now. So Snowflake is awesome. So in this case, I used a large. I executed the same query, and you see that it executed much, much faster that time. In fact, most of our time was just remote disk I/O in that case.
When you suspend and resume warehouse,
Yeah.
you don't just need set of data into?
No. So you would have to, when you're talking about the table cache, you're going to have to execute that query again if you're going to make a different query from the result set cache that was there. Yeah. All right, so that's an example of kind of utilizing, kind of just resizing your data set. You can do that, or resizing your warehouse size at any time, and you can do that kind of as you need. And one of the interesting things I found is a lot of people, you would expect that bad things would happen when I do. I'm going to go ahead and set myself back to an extra small. Yes?
If you shrink back to an extra small, does it still keep the cache?
No.
So okay, so you can't spin up as a large, run all of your queries to get the cache, and then spin down to small.
The result set cache, yes. This is the table cache. The result set cache is handled independent of the warehouse. So if you execute the same query, if I spun up a large, executed a query, that result set would be in the cache as long as somebody's touching it, within a 24-hour period and the data underneath it hasn't changed. That cache will remain independent of the cluster. The table cache, meaning the reduction of remote disk I/O, that will go away. Does that make sense?
What was the table and the cache was by the results of cache?
If it was within that, if it was within the query that made that result, yes. Yes.
So how do we manage like a test and develop environment? For example, do you have a different URL altogether? It's in the same location?
Same location. I would just manage it through roles. Yeah. Same account is what I'm saying. So when you say location, I would manage it in the same account. Generally, what I would do for test and dev, let's say that I've got my prod database, I would create a clone of prod, one of those zero-copy clones of prod, create a test database, and then I would have those guys operate on that. And then you would just authorize the different people. So the test dev guys aren't authorized to do anything on prod, for example, that type of thing.
So they do migrate, let's say, for example, create a new table or something like that. How do you migrate from testing? You have to recreate them in the again?
So there's a promotion flow and there's a refresh flow. So you can take that clone. Let's say that I was doing a schema modification or something like that. I could push that clone back to production, assuming I'm authorized to do such things, through SQL. And again, everything you're going to do is available to be done through SQL. And then similarly, if my test dev guys need the most up-to-date production information, they can refresh their clone. And so that's the way I typically manage it. The reason I say that is because otherwise, first of all, clones are zero-copy clones, meaning you don't pay extra for storage. It's important to remember that in Snowflake, you pay for the compute time and you pay for storage of the data. So if I load a whole bunch of data, you're paying for that regardless of whether or not the warehouse is there or not.
So typically, if you go to let's say store procedure, you take the store procedure copy and then execute them in the production.
You would basically, yes, there is a way to move it back, yes.
So we have stored procedures.
Yes, there are stored procedures.
So there is a way to compare the architecture between the dev test versus the production? And it's all logical anyway.
Yeah, it's all logical, yes.
So these are the architecture, then test is only in production.
I mean, you could do schema compares. At that point, you're just really querying the schema and comparing the schema, yeah. So in number 2, we are going to go ahead and load data from an existing S3 bucket that we have set up. So I'm going to walk you through first the script So you can copy that into a workbook if you'd like and follow along. But I'm going to show you how the script works, and then you guys can run it. This, I know the data is there because we made it. So in this case, this create warehouse if not exist compute demo. If you already have one, you can choose not to run that. This will create the database Snowflake Workshop, and then this will create a schema called JSON demo.
Make it a little larger.
Oh, sorry.
Control plus.
All right. Is that good?
Yep, that's good.
Awesome. All right. What we're also going to do is create a dimension table here and just preload it with kind of all the states in the U.S. And then we're going to create a stage, again, with our super secure, throwing up our AWS secret right here. Luckily, this bucket only has access, only read access to this one bucket. What I would say is we're just doing this so that it's repeatable for people and you don't have to copy in that long string. Go back to the worksheet real quick. I'm going to go ahead and run these things. So I've got my compute demo. I'm going to go ahead and create that database. And you'll see the different changes over here. You just got to click the refresh button over here. And then I'm going to go ahead and create my schema. So if I look here, I'll have, where are you? Snowflake Workshop. There we go. I'll have my JSON demo schema. And then I'm going to go ahead and create my table for state. And then I'm going to load my data into it. All right. So now I've got my data in here. I'm going to go ahead and refresh this guy. So you can see I'll just shrink this guy so that we don't have to look at that anymore. Look at that, I've got my state table. If I wanted to, I could preview the data, and this will just basically do top, and I'll be able to see the data down there. But the more interesting thing is what we're going to do here. So this is the table that we're going to create to hold the JSON data that we're going to pull in. So I'll go ahead and run this. And this table is very, very simplistic. I'll just show you the structure here. JSON data. It's just going to hold the raw JSON data, and that JSON data is just going to be a variant. Now what I'm going to do is create my very secure stage. And this stage is going to have this name. So the stage is created in the Snowflake Workshop JSON demo JSON log stage. And it points to the URL of the bucket. And then we've got the secret key and the ID that we're going to use to access that data. So the stage has been created. What I'll do now is just to verify. I've got my stage. I can see that my stage is loaded here. Now, if I wanted to see the files that were available in the stage, I could just do a list at JSON log stage. And I'll run that. And this is just going to show me a list of these JSON files, essentially. So in this case, I've got these gzipped JSON files. So Snowflake can just natively decompress that and then load that in as it comes in. All right. Now, at this point, we've created our stage, and we've created our we've created our stage, we've created our table that it's going to land in. We see that we do have access, and we can get the files. And you'll see here that we are specifying a file format inline. Now, in this case, I'm going to specify this file format inline, which means I'm not creating a distinct file format just because this is a JSON, and it won't strip the outer array. It's just going to pull in a normal JSON file. Now, this key piece here is a validation mode. Let's say that I had 10 terabytes of data in my S3 bucket. I don't necessarily want to pull in 10 terabytes of data only to find out it wasn't right. So validation mode will return 100 rows of the data rather than all of it. So it's good practice just to run this validation mode first. So I'm going to go ahead and run this. And what you'll see down here is, once it's done, you'll see basically 100 rows. And I'm happy with this JSON data. This is the JSON data I was expecting that it was going to pull, and this data will populate. There it is. So now that I'm happy with it, I'm actually going to do the import. Now, you'll see this on error statement here. I have a couple of different options that I can set for this on error statement. I can say don't load the file if I exceed 1% of errors, don't load the file if I exceed 10% of errors. I can say don't load the file if any error occurs, and just move on to the next file. Because in that stage you saw I had a bunch of different JSON files. So I'm going to go ahead and run this, and what it's going to do is it's going to pull that data over and then just load it into this JSON demo table that we created earlier with that one variant column. And this will take just a second. It's got to pull it from the S3 bucket.
So talk a little bit about if there are errors.
So there's an example that we're going to have next that has errors. So if there are errors, basically it'll skip that row. So we've got a CSV file. It'll skip that row and go on to the next up until you have a predefined limit. So I can define if I have greater than 1% error in this file, don't load the file.
So is there some auditing process to take which files it skipped?
Yes.
Which rows it had trouble with in the file?
Yes, and we're going to see, you can see it'll list out the errors and it'll list out what the error is, and then you can go through and say, well, this file's bad, this file's good, and then you can mark it. You can also say, you can also put in here, I'm going to purge the good data. Like I had a file with no errors, go ahead and purge it from my stage so that I know that that went away. But if I had an error, it won't purge that file. I'll know that I have to remake that file and fix whatever problem created that data quality issue. All right, so here I have, you'll see here that all the data was loaded. You'll see the number of rows that were parsed for things. You'll also see the error limit. So in my case, I just said skip file if there was any error. So my error limit was 1, and I had no errors. So my first error was obviously null because I had no errors. And it'll show you the column if there was an error that did occur. So now that I've loaded that data, and I didn't purge the data because that would be horrible for everybody else who's trying to do this. You wouldn't have any data to pull. Now, in this case, I'll show you the JSON table again by previewing the data.
Can we do this the same thing for CSV files too?
Yep, we're going to do CSV in the next one. So basically, this looks very much like the file did. I've just got the JSON data, and it's got the JSON directly in there. Now, that's great if I just wanted to query the JSON data manually, and I knew all the fields, and I wanted to kind of go down the hierarchy of the complex JSON schema. In this case, what I'm going to do is I'm going to create a view, because I want my BI users to be able to query this data without me having to do anything to it. I'm going to create this view that basically creates a table with city, state, address, zip, IP, record name, those types of things. So I'm going to create this view. All right, and that view is created now. So when I come over here, working with this resolution is super hard. All right, I'm going to preview this data now. And you'll see that I've got a view on that JSON data. I didn't copy that JSON data anywhere. I've just got a view on top of it that makes it very easy to now do kind of natural joins or have Tableau connect to it and just be able to see it very natively. It's much easier to deal with in this form. So now that I've got that, if I just wanted to see the number of points per city I had, this is just a little validation query that we've got in here, the number of cities in the file. So in this case, we've got 578 distinct cities. So there's explorations you can do with this data. What we can do here is a join with that dimension data that we created earlier. So I'm going to go ahead and run this guy. And you'll see here that we've joined it with our dimension data to figure out which region these values are coming from, because we wanted to do a report by region, and that region came from the dimensions table. Don't look at the dimensions table too hard, because I copied and pasted the dimensions table, so all states are in the South for some reason. But data quality, you know, it's good stuff. All right, so I know that we're running up on time here. So what I'm going to do is I'm going to go ahead and go into number 3, because number 3 addresses some of the questions we had around CSV loading, also loading errors, and kind of how we can take a look at that. So, number 3. I'm not used to these buttons being so big. All right. Yeah. All right, so in this case, I've already got my warehouse demo set up. What I'm going to do is I'm going to create a new schema called library in my Snowflake workshop, the database I created in the last worksheet. That context, because I created it, is already set up here in my context of the worksheet, so it's good to go. So what we're going to be doing here is loading about 6-7 gigabytes of library checkout data from the Seattle Public Library. So we've got about, I think it's 12 years of checkout data from the Seattle Library. So I'm going to go ahead and create the table for the checkouts. Now this table aligns with the columns that are in the CSV file that are going to be ingested. So my item barcode, item type, my bid number, all of those are the columns of the CSV file. And then I'm going to create my inventory. So the first table is kind of my transaction, that's all my checkouts, and then my next one is the inventory so that we can actually join that and see who wrote the book, you know, what category the book is, that type of stuff. All right. The next thing we're going to do is create a file format. Now, in the last example, I just created a JSON file format directly in line. This one, I have a few extra little things I've got to set, so it's advantageous for me to create a file format and store this file format in that schema in case I've got any other jobs that need to use this same format. In this case, I'm going to be loading a CSV with a field delimiter of a comma. I could use a semicolon, a space, whatever. You can have two. The field headers are optionally enclosed by a double quote in the CSV file, so they've got the double quotes around them. And then I'm also going to skip the header because the first line is the header information. I don't want to try to process that as part of the data. So once I do that, I'm going to have a file format now. And in this, I'm going to create the same stage. The only difference is that this stage is now pointing to a different folder within that bucket. So it's not like I have to do anything super crazy to change that. I just changed the URL of my stage. All right, so in this case, I'm going to just show the stages like I did the last time. So in this case, the only stage I've got in this schema is the stage I just created that goes to that library subfolder. And I'm going to go ahead and list the files that I've got there. So I've got a bunch of different files of massive size in S3. Now, this is a fairly useful component. So I've got all of the data, both the transaction data, the checkouts data, and the inventory data, and a data dictionary all in the same folder. So what I can do here is I can use a regex pattern to determine which files I want to load into which table, because I don't just want to try to load all the files and fail. So I'm going to pass this regex pattern here using this library load stage and using the format name I created earlier. In this case, I'm using a skip file of 1%, which means if I exceed 1% of errors on this file load, don't load the file. And again, because this is a gigantic load, I am just going to do return 100 row validation. And you can see here that it does look okay to me. I'm pretty happy with this. So I'm going to go ahead and do the full load. Now this will take a couple of minutes. To the question that somebody had earlier about loading Azure to AWS or AWS to Azure, you'll see a little bit of difference in terms of the time it takes to load from that external stage if you're saying crossing regions or crossing to a different provider. Generally intra provider is going to be a little bit faster, but it's not going to super break the bank. The other thing I will mention at this point, for people who are worried about transiting the internet, Snowflake runs its own VPC. You can't really put Snowflake into your own VPC. However, for example, in AWS, you have this feature private link, which basically allows you to consume a service in AWS without ever touching the internet. It goes internally through AWS's network, so that if you have any sort of internal restriction that you cannot transit the internet with this information, you can use something like private link, and Snowflake does support that. All right. So I managed to talk enough to load this data. All right, so in this case, I loaded my inventory. So my inventory, I'm just going to go ahead and see how many books I have in my inventory. All right, so I got about 2.7 million books in my inventory, or books and DVDs, I found out. All right, now what I'm going to do is my checkouts. Now this is the big one. The checkouts span multiple files, so I definitely want to validate this one out first. So this one is very good. So what I'm going to do is I'm going to go ahead and run this and actually load the data in. Oh, unexpected select. You see, this is what happens. Semicolons every time. All right, so what's going to happen now is it's going to load the data. And this is where you're going to start to see some errors pop up because there is some data quality issues in these files. So that some of them have dates that aren't dates. Somebody just typed in random jargon. You'll see there's a couple of different things, and you'll see kind of how those errors pop up. This will take about 3 minutes, so I got to figure out what to say for 3 minutes. In terms of how this is actually working in the back end, it's actually just doing a parallel pull from this external S3 bucket. This could be Azure Blob Storage, or this could just be an internal stage that you created within Snowflake. Again, let's say that I was loading this data and I wanted to have the copy purge the data. There's another essentially configuration I could put on this that would purge the data after I loaded it. So I'm going to quickly show you while this is running kind of the features you have when you create a file format and a stage. So you'll see this is the file format we created earlier through SQL, but you can do the same thing through the UI if you so desire. These are the different formats you can load. And again, like I mentioned, that it internally does convert it into Parquet to load it in, or to Parquet, to JSON to load it in. The compression method, it can auto-detect it, or it can use a specified compression mechanism. So if you had the data compressed on the remote side, how does it uncompress it when it gets to you? The column separator, the row separator, these are unique to the format type that you use. So if I choose, for example, Avro, you're going to have different options. XML, you're going to have different options. So you have a bunch of different ways that you can load this data in. That's when you create the file format. Now when you create the stage, so you can see the two stages I've created and which schema they belong to. If I create a stage, you can see the you got the internal stage, you've got the S3 stage, and then you've got the Azure stage. So again, it doesn't matter what cloud you're on, your stage can be where your stage is. Here, this is where you kind of set your information. And again, this is probably, if you're using like S3 encryption that is self-managed keys, then you can place in your master key information here. In terms of actually creating the stage, generally an admin would create the stages for everybody so that the secret key is not exposed to anybody, right? And then, yeah, so I'm going to see if it's where we are in the, all right, so we got some partially loaded things here. So that took 2 minutes and 27 seconds. So you can see that we've got our error limit, and we have errors seen. So let's take a look at what our errors were. We've got our first error, end of record reach while expected to parse, and then you can see where that error occurred. So you can get some information around where the errors in the files are and what your most problematic files are. I don't think in this, you'll see that some loaded without error. The ones that are loaded partially means that they saw one or more errors. None of them failed, which would indicate that they had exceeded the 1% maximum error that I specified in the skip file. So did that kind of answer the question you had earlier?
That is true. In terms of loading and hitting the limit, does it complete the process for a file before loading any data, or is there a rollback going on? What happens if it hits the error limit?
So let's say that I hit the error limit, and I hit the error limit, and I set it to 10%, and it hit 10% at the last row. None of that data from that file is loaded.
So the load hasn't happened. It's not a roll.
No,
it's
no,
a
no.
transactional roll.
No, it's not. It's not a transactional rollback. The transaction simply would not complete on that. You would never have effected a transaction prior to the load getting all the way to the end.
Something is happening to make sure all of the data is okay before any loading occurs. It's not dependent
Right.
And Oracle's telling me the row is not acceptable.
Right.
In this case, no loading occurred, so all of that determination that all of the data was acceptable occurs before the first row is loaded in each file.
Technically, yes.
Okay?
Yep. So, all right, so now that this is loaded, we can go ahead and take a look at how many checkouts we have. Semicolons. All right, so we have a roughly 92 million checkouts that we loaded here. All right, so let's just do something a little interesting. Randy wanted to find out what the most popular day to go to the library was. So what we're going to do is we're going to execute this query to figure out what the most popular day. Nobody goes to the library on Sunday in Seattle, apparently. But outside of that, the frequency is pretty okay for the rest of the days. Yeah, Wednesday's the highest. Reduced hours on Sunday. So what I'm going to do now is I'm going to actually speed forward here because I know that we're going to be running up on time, and I want to show you the time travel. So I created the dictionary. The dictionary just allows us to see different things. I'm going to copy the dictionary in. That's a very quick copy. All right, so in the dictionary I have 555 records. And I am a very bad person, and I'm going to put in this bad data. So in this case, I've loaded, and now I'm going to have 557 rows, and I do. All right, now I want to see what happened before this crazy person got into my database. Oh, where are we at? Select. Oh, haha, see? I didn't create the database 5 minutes ago. This is the fun part. These time-based databases, when I'm traveling back. All right, let's go with 40 seconds ago. All right, so 40 seconds ago, I had loaded the one invalid record, but not the second one. So I'm at 556. So I can query at different times, but more importantly, let's say that, because I'm like I said, let's say that I loaded my 92 million records. I'm going to go ahead and drop checkouts. Oh, can't remember if I went plural or not. Oh, you know what I need to do? That helps. And now it is plural. All right, so now I just dropped my transaction table of 92 million rows, and somebody's really mad at me. It's back now. And it'll keep it by default for 1 day up to a max of 90 days. That is very helpful. The other thing is, in the case where, let's say that I've got my dictionary that I loaded, and I didn't just drop the table, I'm going to go ahead and create a new table with a different schema. What I can do is, I can show the table history and see that, okay, there's two versions of this table, and something here is different between the two. So what I'm going to do is, I'm going to take my current table and rename it to wrong dictionary, and then what I'll do here is undrop the original table dictionary. So now I've got version 1, the most recent version, which is wrong dictionary, and the previous version, which is dictionary. So I can now start to do compare and contrast. What did my crazy DBA do? You know, that kind of stuff. So time travel is a massively useful feature, especially if you're talking about dev test or just straight up production issue.
And there's no EC2 issue here. This is all about underlying storage, right?
So in the case that you're looking at here, a lot of this, until you actually start looking at the data, a lot of what I'm playing with here is metadata. When you actually start looking at the data, a lot of this is S3, EC2, unicorn magic going on right now. Yeah. I found when dealing with things like Snowflake, I just relegate a lot of the behavior to unicorns. So that's essentially what we've got. I'm going to quickly show you what it is to connect to Snowflake from Tableau. It is I click the Snowflake button, and I put in the server, and I put in the role, and I put in my password.
Can you expand or hold up just a little bit, Chris?
That I don't think I can. That's a well, I can try to change a resolution, I guess.
Your easy views.
All right, so let me try to see what I can do here. Let's see if Tableau respects this. No. Is that roughly better? Okay. All right, so here I'm going to select the warehouse that I'm going to use for my compute. I'm going to select the database. So we were working with the Snowflake Workshop database, and I can select my schema. So I've got my library data I can look at. So then I can start doing the interesting queries that I want to do. I mean, that's as simple as it is. Now, in terms of, let's say I wanted to bring in my Salesforce data, I'm going to use a tool here called Fivetran. So I've got a Salesforce Lightning dev account that has some sample data inside of it. And you can see that here with my, my connectors. It's not doing anything right now because I have taken away the role, I've taken away the user that my ETL user is going to use. What I'm going to do right now, and I'm rushing through this a little bit to just kind of show you what we're doing. There we go. So what I'm going to do here is I'm going to create a role for my ETL service, a Fivetran role essentially. And I'm going to grant it sysadmin access to compute demo and to create a database for this sales data, and then allow Fivetran to get access to that. So I'm going to go ahead and try to expedite this and run all the queries. Never. All right, create role if not exists, compilation error, unexpected role, create. That is not an unexpected role, and I put all my semicolons there. You know what we can do though? Fivetran makes this really easy. Warehouse, edit connection details. This is how, oops. This is how simple this can get. All right. And then my default warehouse is going to be demo compute. My password is going to be awesome. There we go. So all I'm doing here is I'm granting the role to Fivetran to this user, and now I'm going to switch over to my sysadmin role so that I can do the specific things I need to do. Demo compute. And then I'm going to grant all privileges on this warehouse. And I'm going to create my sales database. And theoretically, I can run all queries now. Yay! All my queries worked. So basically, from now, all I just have to do is go back to Fivetran. And, oh, look at that. My password. There we go. So now I'm connected to my warehouse. I'm just going to turn on my connector. All right, and it is enabled, so what I'm going to do is re-enable it, and it's going to go ahead and sync that data. Click to resync all historical data, start resync. So what we'll see here in a little bit is the data show up in Salesforce. And so what will happen here is Fivetran will just basically pump all that data into Snowflake, and that's basically all there is to it. So when we say integration with different services, Talend Cloud Integration has the same thing where I can just choose warehouse, put in my username, put in my default warehouse to use, put in my role that I want to use it as, and then it's done. And there's a number of different, Power BI is very much the same way. So I know we've got like 12 minutes left, so I wanted to pause here for any questions.